Okay, last set of notes for this chapter is 2 more kinds of inequalities. I think for a lot of you, these 2 will be new. So they're going to be very closely related, though, to absolute value inequalities. I want us to write this note at the top again. So please write this with me. Okay, sorry. Any funky inequality? And we talked about, when I say funky, I mean absolute value, x squared, or a fraction, requires, first, a number line, and second, test points. So today we're going to do quadratic inequalities. That's the first kind. That's considered something funky. So we're going to need a test point and we're going to need a number line. We're not even going to look at these steps because they're pretty much exactly the same as absolute value. The first thing that you are going to do, like absolute value, is change the inequality into an equation. So keep everything else the same, but change it into an equation. And then we are going to solve that equation. So in this case, we are looking for 2 numbers that multiply to 12 and add to 7. So that's going to be 4 and 3. So that gives us then x equals -4 and x equals -3. Now, like absolute value, next thing that we're going to do is we're going to draw a number line. So like absolute value, we're going to have our number line that has -4 and -3 on it. And then we're going to have some test points to plug in. Before we do that, though, I want us to notice the inequality does not have an equal sign. So at both of these values, it's going to be an open circle. So let's choose some values to plug in. I'm going to plug in 0, -5, and then maybe -3.5. Now, let's be efficient here. Our first option would be to plug these values back into the original inequality. That is not going to be kind. I don't want to have to take -3.5 and square it. So the other option would be, we already factored this. This is the same as x plus 4 times x plus 3 is less than 0. So I have the option of plugging my number into either of those. I'm going to do the factored one because I think it's going to be easier. So I'm going to rewrite that. So this is x plus 4 times x plus 3 is less than 0. Okay, so if I plug in -5 then. -5 plus 4 is -1. -5 plus 3 is -2, which will give me a +2. So then the question is +2 less than 0? Of course it's not, so this is not part of our solution. If I plug in -3.5, I will get 0.5 times -0.5, which is a negative number. I don't care what the value is. All I care about is that number less than 0? Well, it's a negative number, so of course it's going to be less than 0. So this is part of our solution. You don't get to stop there, though. You don't just get to say, oh, I found the solution, I'm done. Because the right part of the number line could also be part of the solution. So we still have to plug in 0. If I plug in 0, 0 plus 4 is 4. 0 plus 3 is 3, which gives us 12. So is 12 less than 0? No, it's not. Okay, we are not done. We need to write our solution in interval notation. So our shading starts at -4, goes to -3. Neither are included, so they get parentheses. So that is our final answer. So you should see it's pretty much exactly the same as absolute value. Change the inequality to an equal sign, find your numbers, and then go to your number line. Bless you. Okay, let's try one more with b. Again, first thing that you're going to do, change this to an equal sign. So we get x squared minus 6x minus 16 equals 0. Okay, so if we're factoring, we're looking for two numbers that multiply to negative 16 and add to negative 6. That is negative 8 and positive 2. So that gives us then the numbers 8 and negative 2. Now is when the inequality comes into play. So we have our number line. On it, we have negative 2 and 8. Few things to pay attention to. Because our inequality has an equal sign, at both of these values, it's going to be a closed circle. I'm going to plug in 0, 10, and negative 3. So again, first option, plug into the original inequality, or choose the factored form. The factored form would be x minus 8, x plus 2 is greater than or equal to 0. So all I did was look at this factored part down here. Okay, so let's plug them all in. Negative 3 minus 8 is negative 11. Negative 3 plus 2 is negative 1. So I get 11 is greater than or equal to 0, which is true. So this first part of our number line is part of our solution. If I plug in 0, I get negative 8 times 2, which is negative 16 is greater than or equal to 0. That's false. And then if I plug in 10, 10 minus 8 is 2. 10 plus 2 is 12. So this gives me 24 is greater than or equal to 0, which is true. So this is also part of our solution. Again, you are not finished. Your answer needs to be written in interval notation. Because there are two sets of shading, we have two intervals. The first set of shading starts at negative infinity and goes to negative 2. Negative 2 is included, so it gets a bracket. Second set of shading starts at 8 and goes to infinity. And then we connect them with a U. So that is our final answer. I want to clarify something real quick. What I saw on the day 20 homework, for those of you who turned it in, what a lot of you showed is you showed this work here, and then you showed a number line and an answer. But you showed no way from how you got to the number line to the answer. So in other words, you were missing all of this work right here. If you do that on the homework, you will get no credit at all on that question. Because to me, what that communicates is you found your numbers and then you just looked at the answer key to find the shading. I want to see this work. I want to know what numbers did you plug in and what were your results. On a quiz, on the homework, if you do not show all of this work for the number line, you will not get credit. Okay? Questions with quadratics before we look at the ones with fractions? Okay, so let's go on. We have all these steps above. You don't even need to look at them. Don't bother to look at them. Let's just look at an example. You're going to start this example exactly the same way that you did all the other ones. It's a funky one. It has a fraction. So the very first thing you're going to do is change that inequality sign to an equal sign. Before we solve this, anytime you see, this is called a rational equation, one that has a fraction, what's the first thing you have to do before you even jump in and start solving? Find out what x cannot be equal to. In this case, what can x not be equal to? Negative 2. So we talked about the denominator can never be 0, which tells us x cannot be negative 2. Then you are going to solve. So I think it's easiest if you take that 0 and do 0 over 1, and then you can cross multiply. So when you do that, you get x minus 3 equals 0 times x plus 2 is just 0, which gives us x equals 3. Now, like the previous problems, like the absolute value inequalities and like the quadratics, now is when you're going to go to the number line. Here's what I need you to recognize though. X equals 3 is going to go on our number line. This is the only thing that's different. X equals -2 also does. So whatever values x cannot be also go on the number line. So we get -2 and we get 3. Before we start plugging in, I want to know if these are open or closed circles. If x cannot be -2, that means at -2 we're going to have an open circle because it's not included. For the 3 though, we look at the inequality. The inequality has an equal sign, so at 3 we're going to have a closed circle. Now we need some test points. I'm going to test 0, 4, and -3. We only have one option. You're going to go back to the original inequality. That's where you have to plug in. So we have x minus 3 over x plus 2 is less than or equal to 0. So if I plug in -3, I get -3 minus 3, which is -6. And -3 plus 2 is -1. So I get 6 is less than or equal to 0, which is false. If I plug in 0, 0 minus 3 is -3. 0 plus 2 is 2. So I get -3 halves is less than or equal to 0, which is true. So we will shade in between. Again, you are not done. You can't just say at this point, I found one set of shading, I'm done. That's not the case. We still have to plug in 4. 4 minus 3 is 1. 4 plus 2 is 6. So I get 1/6 is less than or equal to 0, which is false. So then again, final answer is when we write this in interval notation, our shading starts at -2 and goes to 3. -2 is not included, but 3 is. So that's our answer. Okay, questions before we do one more of that kind, and then we're going to have a word problem after that. Okay, let's do a last one of these fraction inequalities. So again, first thing you're going to do is change this to an equal sign. What people most often forget is before they solve, make sure you know what x cannot be. That is the step that students forget most often. So that tells us that x cannot be -1. Now when we go to solve, if we put 2 over 1, we can cross multiply. So we get 3x plus 4 is equal to 2 times x plus 1. This gives us 3x plus 4 is equal to 2x plus 2. If we solve that, we get x equals -2. So on our number line then, remember, -2 is on there, but -1 also is. Because x cannot be -1, at -1 we're going to have an open circle. And then we look at the inequality. The inequality does not have an equal sign, so at -2 we also have an open circle. Here's what I got. So you might have chosen to plug in different numbers than I did, which is fine, but you should ended up with the same shading and the same answer in interval notation. My answer in interval notation is the one in blue that's boxed. I just kind of ran out of room. For your next quiz, you will have a calculator. It's not going to be a graphing calculator, it's a baby one, but if you have some trouble doing some of these calculations, you will have a baby calculator. Okay, it should be pretty similar to absolute value and quadratics. Make it an equal sign, find your solutions, test points on a number line. Again, you have to show the work for testing points on a number line. Questions for me before we do our last example together? Okay, give me 3 more minutes of your attention. This one will be short. A bank offers 2 checking account plans. The monthly fee and charge per check for each plan are shown in the following diagram. Under what conditions is it less expensive to use the low charge plan? Okay, so we want to know when is the low charge plan going to cost us less than the fee saver plan? Okay, so you're going to notice for both plans you have a monthly fee of some kind and you have a charge per check. Here's how that's going to work. For the low charge plan, we are going to be charged $5 per month no matter what. But then we're going to be charged 1 cent per check. Well, we don't know how many checks we're going to write, so let's call that X. So we're going to be charged $5 a month plus 0.01X. So that means 1 cent per check. Same idea with the fee saver. We're going to be charged $1 per month and then 8 cents per check. So that's 0.08X, 8 cents per check. This is the inequality that you're solving now. This is linear. There's nothing funky going on. You don't need a number line. Just solve like normal. So if I move the 1 over, I'll get a 4. If I move the 0.1x over, 0.01x rather, I get 0.07x. Divide by 0.07. And that ends up being 57.1 about. Now we've talked about that's not normally the way it's written. Normally x is written first. So x is greater than 57.1. Of course, I'm going to ask you to write a sentence to tell me what that means. Keeping in mind x is the number of checks. So we're going to say the low charge plan will be less expensive if we use, now realistically, you can't write 57.1 checks. So if we have to be greater than 57.1, we have to use at least 58 checks per month. Because again, it's greater than 57.1. The next highest above 57.1 that's realistic is 58. So 58 checks per month.